Let's take a closer look at isosceles and equilateral triangles. Parts of an isosceles triangle, the two congruent sides are called legs. So this guy and this guy would be the legs. The angle where the sides intersect is called the vertex angle, and that would be angle 1 or angle B on this triangle. The side opposite the vertex angle is called the base. So see how I went across? This is the opposite side, this is the base. And the angles along the base are the base angles. So that would be angles 2 and angles 3. The isosceles triangle theorem states that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. For example, if AB is congruent, and this is the symbol for congruent, it's two equals with the little squiggly on top, is equal to CB, then angle A is congruent to angle C. If AB is congruent to BC, then angle A is congruent to angle C. That is your isosceles triangle theorem. The converse of the isosceles triangle theorem, of course, we know we converse, we switch. So we're going to start with if two angles of a triangle are congruent, then the sides opposite are also congruent. And so in this case, it would be if angle A is congruent to angle C, then AB is congruent to CB. Whoops. Okay, so let's practice. It says find each missing measure. So we can see in this triangle that we have two sides that are congruent. Well, if those sides are congruent, then base angles are going to be congruent. So angle J is going to be 68. And then using your knowledge that the three angles add to 180, we can subtract from 180, let's see, 68 times 2, because that would be the two base angles. So that's 16 and 12, so 136. And if we subtract that from 180, that gives me 44. In number 2, let's see, we have a vertex angle of 106, and then we have, these are my congruent sides. So that means my base angles are going to be congruent. Well, let's see. If I have 180 and I take away 106, that's going to give me 74. I need to split that evenly with these two base angles. 74 divided by 2 is 37 degrees each. In number 3, let's see, what do we have? We have 77 with a 12. I think we've got some items missing. I'm going to go ahead and draw in some congruency marks. That's the only way I can determine the other sides and lengths. Otherwise, without having these marks on our graph, we could not answer this question. But now that I've added them, we can see that, well, y is 12, so yz is also 12. And if 77 is a base angle, then angle Z is also going to be 77. Now the question's asking for angle Y. That's the vertex angle. So let's go ahead and multiply 77 times 2. That's 154. And if I subtract that from 180, I believe that's going to give you 26 degrees. In problem number 4, all right, we've got, these are my congruent sides, so these are my congruent base angles. 5x plus 9 is equal to 8x minus 30. Let's do some algebra. Subtract 5x both sides, add 30 to both sides. This gives me, how about 39 is equal to 3x. Divide both sides by 3. X is equal to, how about 13? In number 5, I see that I've got base angles here. That means this guy is my vertex. I know that these sides are going to be congruent. 15x plus 7 is equal to 23x minus 17. Let's do some algebra. I subtract 15 on both sides, 15x, and I'm going to add 17 to both sides. 17 plus 7 is 24, And I believe that's going to be 8x, divide both sides by 8, and x is equal to 3. In number 6, we have triangle RST. Oh, I don't have a picture. I got to draw this. I don't know what it looks like, but I'm going to draw an RST. It says RT is equal to ST. So I'm going to label this RT is equal to ST. Measure of angle R is 9x plus 2. That's this angle here. Measure of angle S is 13x minus 18. I can see that those are my base angles because they're across from my congruent sides. I can go ahead and set those equal to each other. And let's do some algebra. Subtract 9x from both sides. Add 18 to both sides. That gives me 20 is equal to 9 from 13 is 4. And if I divide both sides by 4, x is equal to 5. Okay, so x is equal to 5. Now let's find the measure of r. I know that r is 9x plus 2. If x is 5, 9 times 5 is 45 plus 2, that is 47. It's going to be congruent to angle S, and so since those are the base angles. To find the vertex angle, let's go ahead and double the two base angles, so that's going to give you 1494, and then subtract from 180 to get the vertex angle. Let's see, how about 86? And I'll put some degree marks on those. All right, equilateral triangles. It says a triangle is equilateral if and only if it is equiangular. So if angle A is equal to angle C, the measure of angle B. I'm sorry, let me start over. If the measure of angle A is equal to the measure of angle B is equal to the measure of angle C, then AB is congruent to BC is congruent to AC. Now, the converse, if AB is equal to BC is equal to AC, then angle A is congruent to angle B is congruent to angle C. So, in problem 7, let's find the missing measures. We know that each of these angles is 60. So, and if it's equiangular, then it's equilateral. Each of these guys is going to be 9. In number 12, if we have 3 congruency marks, we know that each of these sides is going to be 24. If it's equilateral, then it's equiangular. 180 divided by 3 is 60. And in the last one, it's telling us that this is an equilateral triangle. Solve for x and y. All right, well, if I have this side that has a y and this side with a y, let's go ahead and set those equal to each other. Okay, so I'm going to subtract 11y from both sides and add 59. And let's see, that gives me 3y, and 59 minus 23 is, how about 36? So my y value is equal to 12 when I divide. Okay, so let's see, what else do I know? I've got, well, if this is an equal, and it tells you it's equilateral, it's equiangular. This measure of angle R has got to equal 60. So 7x minus 3 is equal to 60. 7x